Thank you, everyone. I have to apologize in advance. I am running on 3 hours of sleep because of the jet lag. So if I bore you, just start shouting and I'll try to wake up. First and foremost, how many of you have heard of the company I work for, Replit? Nice. How many of you have heard of a similar company like Lovable? Okay, Bolt, ChatGPT. Nice, good. That's basically what this talk will be about. The company I work for is a company that is basically letting people build software, programs, things. And I thought of starting this talk by bringing to you some stories. The first is from this doctor, and this is a YouTube comment, and he's like, hey, I am a doctor, I have no knowledge of coding, and in 5 days, I built a full stack app for my clinic. I let my clients track their BMI, my sleep, my exercise, my diet. This is a guy that built an email validation system in a single prompt. This is a guy that built a timer, a Pomodoro timer. This one right here built a stock tracking app and a Trello clone, again, with just a couple of prompts. So the thing that all these things have in common when you're thinking about building products like this, products that let other people build products, is that they have nothing in common. So if you think about like the good old days of no code in like the early 2010s, like all the logical flows and things you would connect together, eventually you either ended up actually asking people to kind of learn a language, a programming language, de facto, if you wanted flexibility, or you ended up having like very structured, like WordPress-like plugins, and in the end you ended up with having very structured platforms like CRMs or e-commerces or blogs, etc. Here, this is different. You can type anything in that box. You can literally type whatever you can come up with. Whatever idea you have, hey, for instance, in this case, I want an app where I upload a video and it converts it to a GIF file and I can download the GIF and I can configure it or whatever. And you have this back. Now, this is clearly something qualitatively different from whatever has come before, like until I would say a couple of years ago. And I'm sure you know this from your own experience, because like whatever you type into ChatGPT, you can type whatever you want and you get something back. And this is a completely different way of building software and building things in general that I will try to hopefully prove it to you with these slides. But first, in order to be able to prove it to you, I would like to spend a few words to talk about how things used to be until a couple of years ago, how we used to build things when it comes to digital products. I'm sure every one of you here saw this screen. This is Netflix. If you are working at Netflix, you are a designer, you are an engineer, you know that your users will basically do two things. They will search for a movie, and they will click on that movie to watch it. Sure, they can take additional actions, skipping forward, maybe dragging the timeline, maybe pausing the movie, resuming the movie, but the set of actions that you can take in this product is discrete. You know in advance what the users will do. And you will design for it, and you will build for it, you will engineer the product for it. Same goes for Instagram. Sure, users can upload whatever images they want, but like fundamentally, Instagram is a discrete product, right? You have a set of actions you know in advance that the users will take. They can follow someone, they can send a message, they can reply, they can like, they can upload, they can publish a story, change their settings, but again, a very constrained set of actions and a very constrained set of outputs. Even complex products like Google Maps fundamentally are still known in advance how they work. As an engineer, it's an extremely complex product, but you know that if you type San Francisco, you will have this screen wherever you are in the world, whomever you are, whatever device you're using. Therefore, you have this framework, right? You have a constrained set of inputs that the user can can take, and then you therefore have a known, determined set of outputs. You have basically a function where the input, n is first, can be known in advance. It's like a very well-defined set of things that you can do in a product, and those set of things will yield a certain kind of result. That set of results will be also known in advance. So if I reproduce the exact same behavior, I will have the exact same outcome. That's the reason why we ended up with a certain rules on how to build these products, a certain playbooks, best practices. And I'm sure those of you here that work as software developers or designers or product managers or marketers even will have heard of them. Starting from engineering. So in the classical world, engineering is first and foremost about reliability, right? So if you have this function right here, and you know that n is constrained and m is constrained, and you know that one will yield necessarily to the other, you as an engineer, like your job is to make sure that that f always yields m. You don't want to type in, like, I don't know, open Instagram and Instagram is down. I'm sure it happened in the past to many of you, like you open WhatsApp and the messages, they don't send, right? Because they are crashing, they have an outage or whatever. Like that is the classical kind of engineering challenge that in the classical world you are optimizing for. And so you have things like SLOs. SLOs is a technical term that the engineering teams usually use. It stands for service level objective. It's like basically, hey, I want to make sure that all these numbers right here, they need to be 100%. So these are like the success rates, right? Every time I send a message on WhatsApp, I expect the message to be sent. So if I type certain words and I hit like the send button, I want to be 100% sure that that will yield a bubble in the screen, and the bubble will have the tick, and then the tick will yield a double tick. So the goal is to have maximum reliability, 100%. This is a typical Datadog dashboard that many of you, I'm sure, will have seen if you are working in engineering teams. And you want to hit them with these SLOs, right? You want to have the so-called triple nines, so 99.999%. The second thing that this will yield is you don't want to reinvent the wheel. So if you have a system that is green like this, right, you don't want to change it. You may want to evolve it, to build on top of it. You may want to tweak it, but fundamentally, you're not changing the whole thing. It's a cumulative, layered kind of like building process. This is like true for any kind of engineering effort, obviously. Here, I'm specifically referring to, let's say, software engineering, but this is true for anything, right? If it works, don't fix it. Same goes for product management. It's also, and design too, it also follows certain practices that are coming from this idea of discrete inputs. So for instance, a classical way of building a product, a digital product, is thinking in funnels. So I'm sure you've heard, like you may have seen this kind of chart. This is Amplitude, typical software you use to optimize products. You instrument it. So let's say that you have a certain number of people that are signing up to your product. Let's say Instagram. You are a product manager at Instagram, and you need to grow the platform, to increase engagement, right? So you might want to measure how many people are signing up, and out of those, how many of them are uploading a picture. And you want to obviously maximize this funnel. You want to make sure that it's as many as possible. Then you start adding a bunch of events, and the funnel goes down, and you want to find out choke points and remove bottlenecks, et cetera, et cetera. Typical product management 101. It's the funnels, you can do them because you know, again, that the input to the S function is well known in advance. You know that a user can sign up, can upload a picture, can like a picture, can follow people, so you can construct this funnel because you know in advance what they will do. You know what set of features you offer. Instagram offers the ability to upload a picture, upload stories, watch stories. This is like well-known set of features. If you're Netflix and you're like, hey, I want to launch a new feature, you sit down with the designers, with the product managers, and you're like, okay, let's launch, I don't know, games, for instance, typical example. Let's launch whatever new search feature. So it's well known in advance. This changed. When when we started having these models, these AI models, that can do these things that are like generating new outputs, not known in advance, all these playbooks, all these ideas and best practices, they stopped being true. Or rather, exactly as with classical physics, and then you moved into like more like quantum mechanics, it's not like they are no longer valid. It's more like that the lens through which you see things made it such that they're no longer enough. So for instance, this moment, I think to me, if I really wanted to zoom in to when things changed, is not really when the transformer paper was published, which is like usually what is considered a seminal moment of when the current AI revolution has started. But to me, it's more like when the sequence-to-sequence models were introduced in 2014. So at this point, 12 years ago, 11. So the idea being, we have, the slides are not loading. That's sad. The idea being that you have the ability of inputting whatever kind of input you want, whatever kind of sequence you want, and then at that point, you get output a different sequence. So at that time, in 2014, it was about machine translation. Google Translate, basically, this was Google Translate. You can put as many words as you want, and you will have an output. And neither the words you typed nor the length of the sentence is known in advance in these models. You have no idea what the user will type, and you really don't know what the model will spit out as a result. And that to me is like the moment things have changed. Because we went from knowing in advance what kind of things the users could do to not knowing it. And then, of course, we had attention and we had the transformers, and like at that point, we understood how to make that sequence of only a few words, potentially hundreds of thousands of words, to scale basically that idea. And that brought us to a complete new way of building products that have very different rules and playbooks that we're coming up with them right now. Like we literally are inventing them as of today. The first change is that the n that is the input to the function of your product is no longer discrete, is no longer set and known in advance. You can type literally whatever in Replit. You can type literally whatever in Cursor, in ChatGPT, in Midjourney. You can type virtually anything, and sure, we may want to debate about the notion of unbounded, because technically these models have context windows and you cannot go past a certain point. But de facto, for what we're talking about here, practically speaking, you have an infinite kind of iterations and permutations of the input that you, as like the person building the product, you don't know in advance. So effectively, you have infinite things that can go into your product, and it can spit out infinite things as a result. The second thing that is less appreciated, I think, I'm sure you can like immediately see what I'm talking about here, because all of you here have had the experience of typing something in ChatGPT, and you can literally type whatever you want, and the guy is going to tell you something. Every single time, you can type nonsense, and you will get nonsense back, but you can still type nonsense. What I think is less appreciated is the fact that if you type the exact same thing in ChatGPT, in Replit, in whatever it is, you will get 2 different outcomes, or potentially n different outcomes. And not only that, but the variance between the outputs is quite large. So in this case, I was preparing these slides, and I literally went in Replit and I typed, make me a habit tracker. And I took 2 tabs, and I just run both of them with the identical output, and I got these 2 results. And they're pretty similar because we're trying to bias the model towards certain design decisions and ideas. So even if they are different, and you may like one or the other, they are kind of similar. This is a prompting decision and a design decision we made, but per se, these models can really go quite wild. And you can have very different outcomes, even if you type the exact same thing. And so this, I think, is probably the most interesting thing about these models. and to me is the most disruptive element of this new world we're getting into, the fact that you can have different infinites. You can have infinite things that you can put into the model, and this model can spit out infinite variations of the same input, which is crazy. Now, what this means is, finally, there are a few more things that are important to point out. We have no idea why these things work. We may know how we built them. We may know how they work from the way they are constructed, but we don't really know what they can do well. So one example is, for instance, before launching the Replit agent, which I think is one of the most successful products in history, we literally had no idea what the agent was truly capable of doing. We found out at some point that it was particularly good at doing front-end UI. And so we leaned into that capability. But we didn't know. We discovered this. And this is a simple example, but I have a trove of them that I can share. Main idea being, not even the people building these models know what they're capable of and how to best leverage them to achieve a certain outcome. I know for sure, because we're partnering with most labs, and it's fascinating how we went from, so if you have a data center, you are Google Cloud, and you took certain design decisions in how to construct your system. You are Databricks, certain ways of using a cluster. If you have customers, and these customers need to understand how to use your product, you can assign your own engineers to the customers to help them, right? Because you built the thing, you know how it's best used, you can literally assign people you train to your customers so that your customers can understand how to use the system. Here, it's vice versa. These labs are literally coming to us, asking us, hey, how can we best make this model for you? Because we ourselves, the labs, don't know what this is useful for. If it's good, if it's not good, it's a complete pivot of, it's turning the system upside down. Because again, we are not building these things, we're discovering these things. We're training hundreds of millions of dollars and see what happens, basically. We're rolling the dice, quite literally. So not only we have infinite inputs that go into the product, not only this leads to infinite outputs, these outputs can be different from each other, even with the same input, and we have no really good ideas of what the arrow even does. Because again, the space is so large, the search space is so large. Now you may wonder, hey, is it actually a good thing that we have this plus right here? This is not really something we can control, and we don't want products we don't control. We're selling these things. What if the product starts spitting out, I don't know, racist stuff? And sometimes it happens. Literally yesterday, Grok started saying something about South Africa genocide or something. And we have some ideas of what that happened. But point being, maybe we don't want these models to be so unruly. But the thing is, variance, this randomness, this stochasticity of the output is exactly what is making the model smart, is exactly what allows us to have this infinite space. You don't want to constrain the input too much, because at that point, otherwise you become yet another, going back to 10 years, WordPress plugin, Shopify. Sure, anyone can use Shopify to build an e-commerce, and you can have infinite variations of the e-commerce. You're still in e-commerce, right? Whereas with Replit, you can build anything. With ChatGPT, you can ask it to make poems, as well as crack jokes and check your doctor notes. You don't want to constrain the input, and therefore you don't want to constrain the output. Variance is a feature. Problem is, users hate it. They're like, hey, why are you telling me that my blood tests are okay, and then I put the exact same picture and you tell me the blood tests are not that good? These users don't really grasp the notion of stochasticity, especially when they are paying for every single output. The marginal cost for running the function, the marginal cost of putting a certain input and getting that output is no longer zero. We can debate whether like the traditional classical way of building software, you have marginal cost approaching zero, but I think for all intents and purposes, it is approaching zero. Not anymore. We're talking about potentially dollars, like units, which is obviously, if you start scaling up to hundreds of millions of users, this becomes quite meaningful for you and for them. And this means that if you have a certain output that you don't control, but you're charging users because you are paying for electricity and GPUs, well, that makes things quite tricky. And you need to account for it, and you need to design for it. And there are ways to approach it. But it's definitely a feature that you need to keep into account of this new model. What this all leads to, I think, is moving kind of away to an extent from the world of engineering and towards a world that is much more empirical, that is much more data-driven, that is much more about almost science rather than engineering, precisely because there are so many things that we no longer can tell in advance. We no longer know. And that to me is the first important takeaway of this new world that we have. We're moving from engineering to a new data-driven, almost like science-like approach to building these products. The typical engineering tendency to deal with these AI models is to just slam as much constraints as possible. My experience with the typical engineering leaders that can deal with these things and have decades of experience is, let's constrain the model. Let's put as much rails as possible to make sure that if you put a certain input, you get a certain output. That is a well understandable tendency. Unfortunately, it will kill the expressivity of the product. It will nerf it. These guys keep bothering me. Yeah, while the thing loads. The second thing that is important to mention is you can no longer do test-driven development. I don't know, again, how many of you here in the audience are engineers, but one way of building reliable software in the old normal way is to add as many tests as possible. So if you're an engineer at Instagram, you will add a bunch of tests before shipping any kind of changes for, I don't know, if you send a certain button, if you click a certain button, you will have a certain output. And you test for it. You can no longer do that. If you have infinite inputs, you can type. So what you actually want to do is not achieving 100% success rate, 100% reliability. You want to manage uncertainty. You don't want to achieve the 3 nines, 99.999% of success rate. Otherwise, you will nerf the model. What you want is to get to what is the acceptable performance for the user. The user is like, okay, I can accept this level of, let's say, error rate for certain constraints, but past that point, you let the model do whatever it does. So, typical example, if you are ChatGPT, you definitely don't want the model to start spitting out racist stuff. So that is not the acceptable threshold. You want to go past that point, but past that point, you let the model say whatever it wants. And that is the secret sauce of these models, of these products. Knowing what your market is willing to tolerate, what the market is willing to accept, and let the model run wild past that point. Other example is Google generative AI answers. Sometimes it spits like falsehoods. So far, they could get away with it. And so right now, they're not putting really that much constraints because they are